All right, so we're going to be starting part 2 of the 8.1 to 8.4 review. So we're starting here with solving for an angle using trigonometry. So this is from section 8.3. So if you need a little more guidance on these, you can watch the 8.3 lesson videos. So here we go. We're going to be solving for this unknown angle here. I'm going to give myself a variable to work with. I'm just going to call it x. So in these problems, you need to know two sides of your right triangle in order to figure out the angle measurement. I'm going to go ahead and label the sides of my triangle relative to this angle. So my hypotenuse is up here, across from the right angle. Then over here is the opposite side of the triangle, and then here is the adjacent side. So we need to figure out which trig function is most appropriate to use with opposite and adjacent. That's the one we're going to use to set up our equation. So opposite and adjacent, that goes with our TOA, part of SOHCAHTOA. So we're going to be setting up a tangent equation. Tangent of our angle equals opposite over adjacent. You'll notice that this is different than when we were solving for the sides just a moment ago because our angle is unknown. So when we plug in all of the things that we know, we end up with something like this. We know both parts of our ratio. What we don't know is the variable for the angle. This is where we need to use our inverse trig functions. Inverse trig functions undo the other trig functions. So for instance, when we have the tangent of an angle, if we want to get that angle all by itself, we have to take the tangent inverse of this. The tangent inverse will cancel out tangent, leaving us with the angle. This is how we're going to solve this problem. Same goes with sine and cosine, So here we need to take the tangent inverse of both sides. And so I'm going to write that out. Let me delete some stuff down here first. So I'm going to go ahead and write this out. So this becomes the tangent inverse of this side. So we'll do tan x. And then the tangent inverse of this side. So on the left side of our equation, this cancels out. Tangent inverse cancels out tangent. They're inverse operations, leaving us with x, the angle that we're looking for. And on the right side, we have something that we can use our calculator to figure out. I am going to go ahead and open up Desmos and show you how to do this real quick here. We can actually use our calculator to do tangent inverse. So let me go to Desmos. It's right here. I'm going to clear what I have on the screen. We're doing tangent inverse of 13 over 16. So let me clear that. To get the inverse trig functions up here on the Desmos calculator, you have to hit the func button for function. And the inverse keys are right here. They have the little -1 right there. That is not an exponent. That's just the inverse symbol. So tangent inverse, and then we'll go back to the main calculator. And we're doing 13 divided by 16. And there we go. That is our angle measurement. We round it to whatever is appropriate. We'll go ahead and round this to 1 decimal place. So this 0 is going to round up to a 1, 39.1. Okay, so we get our angle here is 39.1 degrees. Again, once we get to this stage, we need to use our calculator to get that angle measurement. Didn't mention it, but do make sure that the calculator is in degrees. That is the default there when you go onto the scientific calculator, but it's not always the default for all calculators. So make sure your calculator has a D or a DEG on there. I can show you on this one. There's like a little DEG on the top. A lot of calculators will have like a D or an R somewhere on the top to tell you what mode, what angle mode it's in. D is for degrees. R is for something called radians, and we don't use that in this class, so you don't want it to be in radian mode. Anyway, let's go ahead and do another one of these. And yeah, so here we go. We have our triangle. Same idea. This is the one we're looking for. We're going to label our triangle relative to that. We have our opposite side, our adjacent side, our hypotenuse. And the two sides that we know are opposite and hypotenuse, which means we're going to be setting up a sine equation. So opposite hypotenuse Sine of the angle equals opposite over hypotenuse. Substitute in those values that we know. Obviously, we don't know the angle. That's what we're looking for. Opposite is 26 over hypotenuse is 33. Now, some people are going to be able to switch this really fast. They're going to, after they've done several of these, they know, hey, I'm taking the sine inverse of both sides. That's just going to cancel this out. I'm going to get x equals the sine inverse of this side. Okay. Once you get good at it, once you've done enough of these, if you just want to switch it like this, that's fine, right? We're taking the sine inverse of both sides. Again, cancels out sine, take the sine inverse of this, we're good to go. That's fine with me. Then we need to go to our calculator. And I'm going to go back to the Desmos calculator to show this again one more time. So again, func, sine inverse, main, and we're doing 26 over 33. I'll clear that so we can see. We have 51.98. That 9 is going to round up to a 10, which makes this 52. If we round to one decimal place, 52. Okay. So I get 52 degrees. Pretty simple. We need to know how to put in the inverse in our calculator. That is different than regular sine, so don't just put in regular sine. You will not get the right answer. Got to make sure it's the inverse. All right, and then our last thing here is kind of putting together all of our skills, right? We're solving for the whole triangle. So that means all the sides and all the angles. We're going to end up having kind of two types of these problems. One of them where we're given an angle and a side. That's what we have here. And then another one where we're given two sides. So I'm going to go ahead and go through this. We have options in terms of what we solve for first. We could solve for one of these two sides. I'm going to go ahead and just call them x and y just so I have something to name it. Could pick one of these sides and solve for it. I could solve for this angle really, really easily. You know that the two acute angles in a right triangle are always complementary. So actually, I know that this angle is 70 because they have to add to 90 together. So that's actually the easiest thing to do right off the bat, but it doesn't have to be our first step. So now we know all the angles, and it's just a matter of finding the sides. I'm going to try to solve for x. So x will be the one I solve for. This is the angle I'm going to use. I could use my 70-degree angle too, so it doesn't really matter. Just use one of the angles. This side is my hypotenuse. This side is my opposite. This side is my adjacent. So if I'm solving for x in this case first, that's the opposite side. I need to use the other side that I know, my adjacent. So opposite and adjacent means that I need to be using a tangent equation to solve for this. So tangent of the angle equals opposite over adjacent. That means tangent of 20 degrees, that's the angle we're using right now, equals opposite, which is x, divided by the adjacent, 15.6. Okay. Solving this one is one of the easier ones. The unknowns in the numerator. We multiply by 15.6 to get rid of that. And then we go to our calculator, figure out what this is. I'm just using my calculator on hand here. And so I'm getting, if I round to one decimal place, we'll call that 5.7. We round up, so 5.7. Okay, so now we know the side is 5.7. And at this point, we have a couple options to us. We now know two sides of our right triangle, so we could use the Pythagorean theorem to find our hypotenuse. That'd be totally fine. Remember, a squared plus b squared equals c squared. So we can do that. Works just fine. Remember, c does have to be the hypotenuse. That's the only thing to keep in mind with the Pythagorean theorem. Or we could just go back to trig and do trig again. I'm going to go ahead and use trig. So this time, I'm going to be solving for my hypotenuse. So I want to use something that involves hypotenuse. And I'm going to go ahead and go back and use the side that I was given. So I'm going to be using adjacent hypotenuse this time. So I'm going to be writing a cosine equation, CAH, cosine equation for adjacent hypotenuse. So that's cosine of the angle equals adjacent over hypotenuse. All right, so I'm going to go ahead and do this. Substitute in the numbers that I know. So I have the cosine of 20 degrees is equal to adjacent, which is 15.6 divided by the hypotenuse, which is y. So this is the, we'll say, harder version where the unknown is in the denominator. We got to get that out of there. So we multiply both sides by y. So this becomes y times the cosine of 20 degrees equals 15.6. And to solve for y, I just simply divide both sides by the cosine of 20 degrees. Remember, keeping it exact until the very end when we can just estimate at the end. So now I need to use that calculator. 15.6 divided by cosine 20. And here I get this answer, around 16.6 when I round to one decimal place. So there we go, 16.6. Now, we've solved for all the sides, solved for all the angles, we're done. We've solved the whole triangle, and that's what we're trying to do here. All right, so and then here is the second type of problem that we have when we're trying to solve a triangle. In this case, we're given 2 of the sides and none of the angles. Well, we know it's a right angle. That way we can use trigonometry and such, but we just know 2 of the sides. So we'll need to find our third side and the 2 angles. To find the angles, we are going to have to use some inverse trig. You have options in terms of what to do. First, we could solve for an angle, we could solve for this side, we could solve for the other angle. It just sort of depends. It's up to you. Kind of have to make a choice here. Since I haven't done it yet, I am going to go ahead and solve for one of my sides using the Pythagorean theorem, just to keep that in mind and so as something we can do. So the only thing that's important to remember with Pythagorean theorem is your hypotenuse has to be C. Other than that, the other 2 are interchangeable. This could be A and this could be B, or vice versa. It really doesn't matter. I'm going to go ahead and call this one A and this one B, but that order doesn't matter at all. So Pythagorean theorem is A squared plus B squared equals C squared. So A is 9, B is the unknown one, that's what we're looking for, and C is 12 squared. Okay. Go ahead and square those numbers. We get 81 plus b squared equals 144. Subtract 81 on both sides. And we get b squared equals 63. And then we take the square root. And at this stage, we have a couple options. We could get a decimal approximation. So we could get b is equal to, let's see, this is 9 times 7. So we could get that b equals 3 root 7. That would be an exact value. That would be simplified radical form. So 3 root 7, that's fine. That's very precise. That's a really nice answer. But we could also work with a decimal. Since for the most part, we've been working with decimals, that's what I'm going to kind of expect for you to do. But totally up to you. You can write the simplified radical answer. I certainly won't mark that wrong. Anyway, if I do the square root of 63, I get approximately 7.9. So I could call this 7.9 as well. You can see that here, 7.9. Totally up to you. Either one of those answers is totally valid. Obviously, the exact one is preferred, but decimal is fine for this unit. At this point, we now need to solve for one of these angles. It does not matter which one. I am going to solve for A just because I'm making a choice on that one. So I'll solve for A. Relative to angle A, we have our hypotenuse here. This is a hypotenuse, and this is the adjacent. So we can set up a cosine equation to figure out angle A. Cosine of the angle equals adjacent over hypotenuse. Substituting in the numbers we know, that's cosine of angle A equals 9 over 12. Inverse cosine of both sides, again, that's going to cancel out over here. We end up with angle A equals inverse cosine of 9 over 12. And then we can use our calculator. I'm going to use mine, but you can go to the Desmos Scientific to do that as well, or a calculator you have. And I'm getting 41.4 approximately. Like if we're rounding to 1 decimal place, that's what I'd write. 41.4 degrees. So that is this angle right up here, 41.4 degrees. The great thing about this is I don't have to use trig again. I can just find out angle B really easily. These are complementary to each other. So I'm just going to do 90 minus 41.4. So that's going to be 48.6 when I do that. Yeah. I could have solved for B directly and then used that same idea to solve for A, but doesn't matter. The order is not super important here. We'll get the same answers anyway. So now we know all the sides, 9, 12, 7.9, all the angles. And we're done. All right, guys. Good luck on the quiz, and I'll see you later.